All right, good morning, everyone. My name is Sean Ellis. I'd like to welcome you to our first Shared Learning Program Manufacturing Meetup event of 2024. This event is being delivered through the various clusters that we represent, namely the Durban Automotive Cluster, Durban Chemicals Cluster, eThekwini Furniture Cluster, Cape Clothing Textile Cluster, KwaZulu-Natal Clothing and Textile Cluster, and the South African Automotive Benchmarking Club. So this event is being delivered for our member firms, and we have also agreed, because of its importance, to invite non-members and additional individuals to participate in today's session. As is outlined, the session is going to focus on the practical steps for successfully implementing renewable energy solutions within your organization. Point Solar, service provider, implementer of renewable energy solutions in the Western Cape, is going to provide some guidelines that firms can consider when embarking on this journey. We have had sessions touching on renewable energy in the past, but today's session is really trying to deal with the practicalities of what firms need to do and consider when embarking on this very important element within their organization. In terms of disclaimer, it just highlights that we as BM analysts cannot be held responsible for any decisions made as a result of these particular events. Ultimately, any decision you make and anybody you decide to engage with is at your own discretion. It's also important to note that we always need to adhere to the competition law, and that in this particular session, no practices will be undertaken that contravene the competition law in any particular way. It's also very important to acknowledge our funders. While many of the firms that are participating in today's session are members and do provide funding, our clusters would not operate without the support of the public sector. And in that regard, it's important to acknowledge the eThekwini municipality, as well as the City of Cape Town and Invest Cape Town in the Western Cape for their ongoing support to our various cluster programs. In terms of the agenda, I'm busy doing the welcome introduction. I'm going through it quite quickly because we do have a lot to get through. In terms of the shared learning program, I'm not going to touch too much on it now. I have included some additional slides which will be sent to each of you. We had a very successful year last year. A number of events were held and a number of people participated in the events, and we've got a very exciting year ahead. Obviously, we've got today's session, which is on implementing renewable energy. In February, we have a session on dealing with supply chain challenges, in particular around the ports, and we've got a panel that will be sharing their insights in terms of what firms can be doing to address those concerns, and those invites will be going out very shortly. And we've got some other exciting events planned for the year ahead. We've also introduced a WhatsApp group, which will be another mechanism that we will be able to use to effectively engage with our member firms around sort of upcoming events, as well as recordings and anything of relevance. We will post the WhatsApp link in the chat. If you would like to join the WhatsApp group, you're more than welcome to obviously click on the link. So in terms of, and then obviously the key focus of today's session is going to be the context of Point Solar, and then we will look at having a Q&A at the end. What is important to note is that due to the amount of information that needs to be covered, the presentation about Point Solar is expected to last about 50 minutes. Please post your questions in the chat, where we will look to answer them at the end. If you do need to leave at 12 o'clock, we do perfectly understand. This session is being recorded and it will be shared with all member firms. But I will also state that Point Solar has agreed, Rainer from Point Solar has agreed to hang on at the end to answer any additional questions and deal with any queries. So if you are able to hang on at the end and you have specific questions or queries, we will look to address them a little bit later. We will also release a poll towards the end of the session, an evaluation poll, and I would like to request everybody to look to complete that evaluation poll. All right, with that, I'm now going to stop sharing my slides. Like I said, I've gone through this very quickly because I want to try and maximize the amount of time allocated to Point Solar for their particular session. So with that, Reino, I'm going to hand over to you and allow you to obviously take it away and to provide your knowledge in terms of this particular aspect that firms need to be aware of.
Good morning, Sean. Thank you very much. Can you hear me clearly?
100%.
Awesome. I just want to thank everybody that's involved with this webinar session today. I think this journey will be quite informative. We started, me, you, yourself, in late 2023 when we reached out to Point Solar and we explored the various renewable energy topics. given that role in supporting different manufacturing clusters, like you said yourself at the moment, it was incredibly insightful for us as a company to try and understand what your industry is actually required. Following that dialogue, you requested me to do a small webinar session like we are doing today, just to reflect on what the energy transition would be in South Africa, but more particularly, what the practical steps is that we follow as an EPC company to ensure that we stick within the regulation, which is the latest regulation that has just been implemented in the last 12 months. And also just to give some insights maybe to potential new clients that is planning on a renewable energy journey. Please note a lot of technical information that I will be sharing today. The session itself, we've only got like 50 minutes. So you can imagine we can't discuss everything. And I've seen so many different questions in the polls. But like you stated, we open and free to give advice at the end or even for future communication to anybody else. Just for practicality and functionality and convenience, because we are also in the industrial area and anything happens, sometimes you've got trucks driving past that causes some disturbance issues. So we made some short video clips that we will share during this presentation. I hope we don't have any issues with that. Should there be any issues, we'll try and resolve it as quick as possible on this platform. But that information will also be shared in a post-session output pack, information pack. You can kindly distribute it. Please feel free, anybody else, to use it for your own information going forward, or even with other parties that is interested in this specific journey. I just want to touch a little bit base who Point Solar is. So Point Solar is a member of a collaborative network of companies. As a network, we are totally committed to deploy renewable energy systems throughout the whole of South Africa. Together as a group, we oversee comprehensive turnkey solutions, and thereby we offer specifically engineering and design of systems, the procurement and construction process, operating and maintenance once the installation has been completed, which is also a critical factor in a part. And a lot of people has asked the question, how much does it influx the financial cost on a system? Is it comprehensive? Is it complex to do? Yes and no, it's not. But we tend to provide that specific service, especially for what we'll see later in this presentation for the warranty period, which is now gone from predominantly, it used to be 5 years. It's now actually gone up on most of these new type of equipments to around 10 years. We also offer the services for monitoring and control of the system to make absolutely sure that the system produces efficient power like we designed it right from the start. In some mini grid installations or expanded grid installations, we would do specific metering or sub-metering, where we would provide solar to maybe 1 or 2, 3 tenants in a specific building complex, and we need to sub-meter them individually in terms of their needs. So we handle that sub-metering process ourselves, and then obviously the last of all, we provide finance solutions and options. So we try and really make it a turnkey solution where a potential client will get all the services in one area. Before I start with this presentation, I just want to make a couple of comments regarding the renewable energy sector. And the first one would be is that please keep in mind there is no one-size-fits-all solution when it comes to energy independence. Each system has its own unique characteristics and factors that we need to consider. You can have 2 adjacent buildings with the exact same capacity requirement, but maybe just the roof layout on itself is different. So even those 2 buildings will not have the same efficiency or system design. The second comment I'd like to make is for us to deal with the current energy crisis and even the future crisis heading for South Africa. My advice would always be to have a do-it-yourself approach or an attitude. If you do not take the first initial steps in this process, you will never come to the point where you can actually install a solar system. The beauty about solar is it's modular. You can start small and expand from there. If you feel that you need to learn more about solar, maybe start with a very small system so that you can get the fundamentals of how it operates and how it works and understand it better, and then progress and go larger from that system onwards. The third and final comment that I want to make is that we need to keep in mind, and people might not like the statement, what I'm saying, but the Eskom grid still remains the most convenient, cost-effective, and dependable provider for baseload power. And I want to focus my attention on baseload power. Baseload power is consistent, large volume of power, and that's why I said it's convenient and cost-effective. However, what we need to manage as business owners or residential owners is we need to manage the reliability issues that we've got with this distribution of this baseload power. We've got power outages, and we can only do that with renewable solutions. The cost effect of major plants doesn't bring in the parameters of managing the reliability of a system like that. So I would like to then let my colleague just share. From here on, we will play the video inputs. Just give us a second so that we can transition to that. And should there be, like I said, complications, we'll handle it from there.
Rainer, we're not getting any sound on our side.
I see that. We are working on this.
The renewable energy industry in South Africa is relatively new. Over the past decade, it has predominantly been dominated by large-scale IPP projects and some DIY setups. However, since 2018, there has been an increased demand for larger systems up to the megawatt scale, particularly in commercial and industrial settings. Several factors have driven this increased demand, being increased load shedding interruptions, positive legislative changes from the government in NERSA applications, along with tax incentives, growing trust in the solar technology and its effectiveness, and the availability of extended finance options. For our company, the most significant disruption we've experienced in this industry recently has been the regulatory and compliance changes that took effect in the last 18 months. Most notably, municipalities, and especially the city of Cape Town and the broader Western Cape, have taken a bold stance towards alternative energy supply systems, commonly known as an SCCG system, small-scale embedded generation. This is understandable, as they are responsible for protecting the reliability of the distribution infrastructure, as well as ensuring the safety within the network. We've also observed that plants installed before the new regulation had to undergo component upgrades and comply with the specific SCCG regulation standards, leading to a negative financial impact for system owners and a negative perspective on the industry. It's imperative to ensure that any new system investment aligns with the latest standards to prevent the risk of non-compliance. There have been some shortcomings within the broader industry, especially concerning substandard products that entered the market and a lack of formal training for solar installers as well. Many installers learn through trial and error, which has led to a hesitancy to becoming compliant with the latest standards and regulations. Additionally, many engineering consultants and licensed electricians lack a comprehensive understanding of the solar industry. We often receive calls for assistance, particularly regarding design and integration, with inadequately prepared RFQs circulating the market. It's essential to remember that when generating power at your property, you are essentially establishing a mini power station. So please ensure your compliance is crucial in this aspect. When embarking on this journey, several sectors should be considered, including the design, the integration of the system, the compliance, and the regulation adherence. We strongly encourage businesses to familiarize themselves with the following legislative requirements, namely the DMRE, Department of Mineral Resources and Energy. They deal with the National Energy Act of 2008, which is governed by the DMRE and responsible for formulating and implementing policies related to the extraction and use of any mineral resources as well as energy distribution. Secondly, NERSA, the National Energy Regulator of South Africa, and they are the custodians and enforcers of the Electricity Regulation Act of 2006. This act provides the potentiality for licenses and registration as the way in which all generation, transmission, distribution, trading, and the import and export of electricity are regulated. Secondly, they are also allowed to establish independent power producers to promote competition and increase electricity supply in the country. The next one, we have to look at standards. Standards are published documents that contain technical specifications and criteria designed to be used constantly as a rule, guideline, or a definition. Standards are used to increase the quality and reliability and effectiveness of many goods and services as we know it. ISO is the International Organization for Standards, and they contain around about 15,000 different documents as standards. Locally, we know them as SANS, South African National Standards, and there's around about 6,500 various documents, of which the electrical sector forms part of those documents. SABS is only a testing body, meaning that they control the sampling of product and do the testing of those specific products. The next body that we should look at for compliance would be Eskom, as Eskom is South Africa's main power company, and they control most of the electricity generation, transmission, and distribution. If you want to connect to their system, you need to follow their policies, guidelines, and rules, and comply with their SECG process. Municipalities in South Africa also manage electricity distribution, as well as their own networks, sometimes by buying power from Eskom or self-generation. They too have their own SECG strategy, as well as individual bylaws. Please take note, no one of the municipalities are the same. So make sure that you comply with your local municipality guidelines and rules. Then lastly, I just want to discuss the requirements for a solar installation company. Since this was one of the burning questions in the feedback poll that we received on how to establish the reliability of a solar installation company to meet requirements. The suggestion would be that the minimum requirements should be followed and make sure that the company is registered with the Department of Labor as an electrical contractor and have a valid registration number. The company should also be registered with MBCEI, which is the National Bargaining Council for the Electrical Industry, as well as the ECASA, which is the Electrical Contractors Association of South Africa. The company should at least have a full-time employed licensed wireman's electrician to oversee the actual installation work within the construction process. This installation electrician should also be registered with the Department of Labor with its own unique number. The company should at least have access to a registered ECSA PR engineer who acts as the responsible person to sign off on all electrical drawings and compliance documentation, especially in the SECG application process for any system above 30 kVA or kilowatt. And then lastly, at least some industry acknowledgement, whether it be via the Sapphire portal or PV Green, just to show some accreditation membership for the company itself and some training certificates for the employees or the installers that did some accredited training. Please also have a look at the policies and procedures, especially regarding the safety, health, environmental, and quality systems. As a service provider ourselves, we typically follow this workflow roadmap to ensure all the necessary steps are followed to ensure project success. Each one of these points will be discussed individually in the next few slides. Step one, after receiving a client request to have a potential system installed at the property, we would generally send out an RFI document. The reason why we send out a document is not to exploit cost and keep the time management in frame for everybody. This document needs to be filled in properly by yourself, because you need to know and understand and give us the information regarding what your actual requirements would be. What we intend to do with this document is to get the feasibility of a potential system to be installed, without really delving into deep and escalating cost, like I said before, for yourself and for us as a company. And that's the basic principles. After receiving the RFI document, we would be able to establish whether or not a system is feasible for the actual business. We would then consult with you on an online session that takes normally between 2 to 6 hours, and we require senior management to be involved in that meeting to discuss the final details. Crucially to understand in this point is that it's leading up to the actual site inspection. So we need to make sure that all the arrangements has been made that will facilitate the inspection, the actual site inspection. So obviously your point of supply is crucial. Do we need to investigate your substation? Then it has to be communicated to your supplier, your municipal area or your ESCOM. That will give us the opportunity to investigate the transformer, the mini sub or the kiosk or the actual meters. From there, we will also look at your client policies on site, your procedures, and what your requirements would be in the consultation to handle the safety, health, environmental, and quality issues that you expect from the overall installation, and what the key factors would be in your industry. Please note that it's very important for us to understand your industry-specific needs, as we might not be aware of all of them. And you need to relay that information to us as clearly as possible. We will also describe or discuss the system type that you plan to install, whether it be off-grid, a grid-tied system, hybrid backup power, and what the requirements may be, and we can discuss the intricacies of those a bit later. But during this consultation meeting, we will definitely try and establish what is potential and what is possible for your actual area. Critically is the finance options in this discussion. Would it be an outright purchase, a rent-to-own system, or even a power purchase agreement? And that is why even your financial manager would have to discuss in this online session to make us understand what is the budget or the requirement before we go any further in terms of exploiting cost, like we said before. The next step for us as an organization is the most important and critical part of the whole development of a project, and that would be the site inspection. Generally, on a site inspection, it would be attended by either a project engineer or installation electrician to come and check out the systems. They will typically look at the workflows and the method of your current organization, just to make sure that we can integrate with your operational structure while doing the actual installation. They would typically look at the building general layout, how many levels there are, single level, multiple levels where we might need craneage or access and those type of things, as well as lay down areas for the typical equipment. Please keep in mind solar panels, once you're talking about a large system installation, you need quite a bit of space as a construction area to be able to install these type of equipment, and that needs to be investigated. They will look at the roof layout, the integrity of the structure, can it handle the load of the actual PV modules or the array, the material type, in order to determine the type of installation methods or the system that should be incorporated. They will look at the space, specifically the egress, in terms of safety for the personnel, not just for the installation itself, but for future maintenance purposes as well. You might not necessarily see the shading effect it might have on the building, and that would be investigated. That's why a typical site inspection would normally take a full day, from early in the morning till late in the afternoon, and that's how you would get the correct data to be able to design a proper system. They will also inspect the power supply points. That will be generally your main distribution DB and all the subsequent sub-distribution points or distribution DBs that's associated to the main network. And they will look at your equipment in those DBs. Are they functional? Are they still in range with the latest regulation? Can they handle the capacity of the added or installed energy provision? They will do some measurements, actual testing with different devices, and make notes of these. Sometimes they will even advise to upgrade the existing system, especially when you find older buildings that's like 30, 40 years old. You have to redo the whole distribution DB, maybe even the cabling, to be able to do a new system layout or design. The energy meters will be inspected, the type of the energy meter, whether it's smart meters, conventional meters. We will try and extract data from those meters to give us an energy profile over a set duration, maybe a year, and we'll also look at the functionality of those type of systems. When we talk about an energy profile, it will be regarding your not only your usage, but more specifically your peak demand and your load, your average load. So you might have a system when you're looking at the bill or your monthly statements that will tell you you consuming, let's say, X amount of kilowatts. But if you look at the actual peak demand, you will see that it's a factor much higher than what is your average load. So you might be developing a system in the 100 kilowatt range, but in the meanwhile, your peak demand might be 300 kilowatt, and you need 3 times the inverter capacity. Your power quality in terms of power performance or power factors and kVA ratings will also be looked at to try and see the efficiency of your system. Can we incorporate devices or additional equipment that can have soft start on motor start, inrush current equipment that is much more cost effective than what an actual enlarged solar system would be. We will look at voltages. South Africa has got a tendency with what we call dirty power, where we've got huge voltage drops between high and low. And those voltage drops then obviously affects the system and the operating part of the system. And we need to establish whether or not we can add different devices to keep that process stable. We will definitely look at your equipment, whether you're in manufacturing, whether you're using in the textile industry, and it's mostly small manufacturing equipment or large-scale equipment with heater devices or cooling, HVAC systems, suppressed cooling. Those need to be calculated as well in the system, and we need to ensure that the total layout of the system is capable of what your requirements would be. I just want to add here that predominantly this is where most of the potential installations fail, and it fails for 2 reasons. And the first reason would be that the person doing or conducting the actual investigation is not knowledgeable regarding what they should look at. And the second factor would be the client not being transparent. Maybe they're scared of the existing network or system, and they're expecting that it would be a huge cost implication to them. But I want to give a word of advice, rather to be transparent in this specific investigation, because that will make the make or break of a successful system. Step 4, after the site visit, we will then investigate a due diligence regarding the compliance with the local municipality or your ESCOM supply to ensure that the bylaws and regulations are followed for the actual specific installation that you require. The way leaves and agreements will also then be signed or applied with each authority or industry body. And keep in mind, you might even have your body that might be involved with the installation of your system, and they need to give the authorization with regards to how it should be done and how it would affect them, and it needs to be described to them as well, which is quite important to have those agreements in place prior to the establishment of that system. Step 5 in our roadmap would be the design phase. And I just want to add to that, contrary to popular belief, it is impossible or nearly impossible to pre-engineer a solar system to function flawlessly. Numerous factors will implicate or impact the performance of a system. And the biggest factors for that would be your environmental factors. So your weather condition, the landscape, and even temperature differentiation will have an impact on each system. When you talk about weather patterns, there's a difference between sunlight in summertime and wintertime, and you can imagine that the eye radiance in summer is much higher than that, but it is in winter. To mitigate the actual design or the total design, we use different softwares that predicts the weather environment on this particular area, like we said before, your geoscope or your actual location of the building, as well as we use data sources, weather patterns in the actual design. From there, we would make an equipment selection. We would look at the quality of that type of equipment and whether or not the warranty issues might prevail over the duration of time, especially in coastal areas where you've got your salt and high humidity. We need to ensure that that type of equipment is approved for coastal conditions. We make sure that we use the most advanced technology that's on the market and not the cheapest. And the reason for that is because we want longevity of the system itself and to have peak performance. Once we have done this selection of equipment, we would then draft a set of drawings, which will include a single line diagram, a current roof layout with the solar panel layout that we are anticipating, as well as a structural assembly of those specific panels, whether they attached directly to the roof or angled on brackets, or maybe even a carport structure or a ground mount system. We would also look at the equipment layout in terms of the internal building to make sure that it integrates with your current network or electrical supply. From there, all these documents then will be reviewed by a project engineer. He will comment on it or do an acceptance and sign the documents off, whereby this will then go to the next step, which is the submission to all the industry bodies. The next step in our roadmap would be to do a costing, and normally the financial department will do a detailed quote with each line item indicating the PV modules, the inverter, the battery, and the AC and DC switchgear, as well as the cabling that's going to be consumed for the specific project. What I tend to believe in the industry, what I haven't seen in so many quotations, is that people tend to leave out specific model numbers. We find that to be very important to make sure that the actual design and the quote reflects the same equipment. We've had this question before in what is the average system cost. Like I said before, there is no one size fits all solution, and the best would be to rather take a proper design and do a system cost. There is some general information out there that will tell you that a grid-tied system will range between the 15,000 to 20,000 range, and a backup power between 30 and 45,000. Hybrid solutions between 45 and 50,000, and off-grid systems 50 to 60,000 rand per kilowatt. Please note, this might be an average, but there are some system installations which are rather simple, and that will obviously reduce the cost, but you do get systems that's more complex. Keep in mind that we need to look at your existing infrastructure network as well, and that could have a significant impact on the actual cost. That brings us to the next step of the process, which will be your contractual and finance, where we would sit down and actually agree to a system implementation and how it will be paid for, and what the responsibilities in external budgets or financial model would be. Now, I understand that this has also been a request on the poll, that how do we model a solar system, whether it be from the initial point of view, or the return on investment part, or what the operating and maintenance would be. And I just want to highlight that once again, there's no one size fits all solution in this scenario. The first option you will have is to have a cash purchase. So we will come up with the finance, pay for the system, have it installed, and then you'll have to operate, maintain, and warranty claim it on your own, or have a contractual agreement with your current installer for, let's say, 24 months. The other option would be to get a credit finance from major banks. That has also become relevant in the last 2 years, where the 5 major banks has agreed to do solar financing in the renewable sector. Or alternatively a rent-to-own system. Typically, this will be a much smaller systems and not large-scale commercial industrial systems. And I would generally say it will be up to the 50 to 100 kilowatt scale, and not more than that. But please keep in mind, with all these options, you still need to consider the external cost and factors that will come into play, like your warranty terms, your conditions, especially on your insurance. Please notify them in advance that you've installed solar, and they need to escalate or change their policy regarding the solar installation. That's a major part that most of the clients tend to forget. And if there are any issues, this will not pay back as required. Keep in mind that you also will have repairs. Most of the system components are only warranted for 5 years, and maybe an extended warranty up to 10 years. And you need to keep in consideration that you will have to replace some of these components individually or as a whole. Not really that much, but it might happen. Keep in mind that you will have to employ somebody that can understand the system, so that you can operate the system efficiently, and obviously maintain it. Maybe have a crew on site that can clean the panels, make sure that your electrical system is still up to date, and it falls under the warranty process as well. The way that you operate and maintain the system will implicate your warranty process. Please keep in mind, most of these systems are internet and artificial intelligence driven, so they have backup data. You cannot turn around and say that you overuse the system. They will pick that up immediately, which will affect your warranty claims, and that becomes a crucial factor also. The benefits of doing this in a financial model would be your tax rebates. And like I described before, the government actually granted us 126% incentive for tax rebates in the first year, claiming back on the system. This has been discussed in previous sessions, and I won't further go into that. My final discussion that I would like to have is the PPA, or the Power Purchase Agreement. That's also been everybody's lips and question regarding that. And to try and describe it in a very, very simple term is that there's no capital expenditure from the company itself. You would have a provider or installer that will install the system free of charge, sell back the power to you at a reduced rate to what you are currently paying. The other benefit would be that your annual escalation in terms of tariffs will be much lower than what your NERSA annual escalation would be. The system will be operated and maintained by themselves. They will carry the warranty, they will monitor it, they will operate it, and also over the duration of the project, you might end up owning the system over 10 or 15 or 20 years, depending on the contract and the terms of the contract. So in essence, it makes it very simple. If you do not like to be involved with the actual integration of the system and maintaining and operating, is to have somebody externally that can offer you a power purchase agreement. The only unfortunate part about power purchase agreements is that it has to be projects of scale. So generally, power purchase agreement gets offered from the 100 kilowatt and upward scale up to 10 megawatt. But you need to ensure that the provider or the installer that offer these type of agreements can honor those type of agreements contractually. And you have to do a due diligence to make sure that they can commit to the contract duration, in a sense. Step 8 of the roadmap would then be your regulatory and compliance approval and submission process. This is where you would initially propose your SECG system, small-scale embedded generation system, to your current energy provider, either Eskom or the municipality. They'll have to look through the details like we discussed in point 5 when it comes to the design. And once the project engineer has signed it off, you will do a submission towards them. They will review it and make recommendations regarding your application. Please keep note that this is also a time frame constraint, as especially in the Western Cape, where you need to apply before you can get an approval letter to install. Once the approval letter to install has been issued or awarded, then you can carry on with the installation, and then the final process will then be to test the system. Once after commissioning, they will give you a certificate or an agreement between the owner of the system and the actual provider. I just want to add here that each municipality's got their own regulation, like I explained before. Even in Eskom, when they are the supplier, you need to stick to the bylaws and obviously to the grid impact studies that they're suggesting or the guidelines that they give you. You don't want to get yourself to the point where you have installed a system and it's not compliant and you have to make huge changes because you have spent the money already, and you want this process to be transitioned fairly quickly, as you want to reap the benefits of having this renewable energy system. Once you have received your installation approval letter from the required industry bodies, your neighbors, your homeowners association, then it gets to the nuts and bolts of the project, which is the most exciting, obviously, the actual installation. So we would go through a procurement process, placing orders with different manufacturers. There's most probably a lead time, especially on larger scale installations, so that takes between 1 and 12 weeks. For manufacturing of the equipment on a specific specification technicality, transport and delivery to site. The actual installation will take place, commissioning of the system, testing in a specific duration of what was prescribed, either a week, a day, or a month. And once all has been done, the project engineer and all the required personnel and professionals will come to site to certify the compliance of the system and issue and warrant all the necessary documents for that. Once you have received all the documents, you will submit that for warranty registration, and most of the suppliers would then give you an extended warranty period offer, whereby they might offer you a 5-year warranty period and with an additional small fee, and a proper documented system will extend it to 10 years. Please note, it's very important to keep this documented system in an archive, properly protected for at least 10 years. It's rather simple to understand that these are the set of documents that will describe or prescribe what has been installed. You might need it for future reference or changes into the system, and at least you've got it. Like we explained, we have notified the insurance company, but now is the time to actually notify them that the system has been installed. You will share the required certificates of compliance to them, and they will then make the necessary adjustments to the policy to make sure that the system is incorporated into your policy according to what their requirements would be. All the other regulatory documents, like we discussed, will be submitted for approvals with the industry bodies, more specifically the municipality, that will then award you an actual certificate stating that you are now solar capable, and there is a contractual agreement between yourself and the municipality. This document will also require for you then to be submitted to a further industry body, which we call PB Green, and they will then offer a certificate of installation and add you to the database for the Sapphire database as a renewable energy supplier. The final step in our process is after the installation, but it's actually a continuation while the contract duration is of effect. This is our maintenance, monitoring and control process, or part of the roadmap. And like any post-surgery care, the operating and maintenance of a renewable energy plant or system after the installation is critical to ensure that the product warranty period is attended to. The maintenance of the system will ensure longevity and component protection, and monitoring will ensure that optimal performance and efficiency of the system is available. We take control of the system and the operating functions of it to maximize the benefits of the total investment. Regular inspections is also required in order to stay within compliance with the OSH Act and the electrical regulation, and to ensure that your insurance cover is protected. To explain or highlight the benefits of a typical solar system, I would like to showcase the following ECCG example. For this business, Brighton Body and Spray, Mr. Mike van Eyck, located in Cape Town, is also part of the automotive repair industry. The specific contract that was signed is a 10-year PPA agreement, and the installer in this case in the network was Swill Solutions. Swill Solutions also internally financed the system, and it's a hybrid system. As you can see, the implementation date was in February 2023, which gives us an operational duration of around about 11 months. The operating hours for this exact business is 7:30 in the morning till 5 p.m. in the afternoon. The overall benefits that was received out of this installation was a 125% tax rebate in year 1. Up to date, they had 0 power interruptions, an overall 20% reduced cost on the electrical bill, an 80% reduced cost on diesel generator expense. They increased their manufacturing approval and included Kia and Hyundai to their panel. They had a 30% increased production throughput since the installation system was installed due to no power interruptions. All of this made him achieve to win the first place gold award for the Western Cape, as well as the third place bronze award nationally, out of an industry perspective. If you look at the system, you will see there's a 100 kilowatt hour battery installed, as well as an ATES inverter of 50 kilowatt, and more or less 50 kilowatt of PV modules or array on the roof. When you look at the ATES dashboard, we normally look at this information to understand the efficiency of the system. When you look at the PV generation slide, you will see for the day it's already produced 105 kilowatt hours that was effectively used as a cost energy saving and also on a green initiative. If you look at the last slide on the my photovoltaic devices, you will see over the duration of the 11 months the total energy consumption, or the total energy produced for the system, is 4,989.5 kilowatt hours, which is generally considered as 5 megawatt. Not bad for a small implementing system and very successful. We have received some pre-event questions that I will answer briefly. The first question: what sort of certificates or accreditation should a solar installer have? And I think we have covered that specific answers on that question. The second question: planning and implementing a renewable energy solution for a new factory build. I would strongly advise to get a solar consultant involved right from the start. Notably, to collaborate with the architect, and the specific manufacturer to consider is the roof layout. They should also consider the type of equipment and the specific building needs for a renewable energy system. Is the technology for solar improving, or is it plateaued out currently? We constantly see changes in the manufacturing sector. Improvements on solar panels is continuing as the efficiency is also generated more predominantly over the last couple of months with new technology coming available, as well as the changes in battery chemistry and in increased and enhanced capacity factors that we're witnessing. The last question: disposable renewable energy components after the end of life, and what infrastructure does exist in South Africa for waste disposal? Currently, there are no approved recycling or waste disposal facilities that we are aware of, but we strongly believe the reason for that is because of the operational life cycle that is not at the end of life at the moment. However, we do feel that within the next couple of years, this will become a lucrative business to pursue.
Thank you, Sean. I think that is where our presentation will stop, and we can continue there.
Great. Thank you very much, Reno. And yeah, thank you. I know this is not your normal comfort zone, so I do appreciate sort of how you went about it, and I think it's really useful lesson from our side. But yeah, I think you covered a lot in that session. Yeah, so just to maybe we do have some questions in the chat, but before we get into that, maybe so thanks again. So just to put in context, so like as I mentioned up front, a lot of firms have said, they know they need to do this, but they just don't know where to start. And there's all this sort of like, red tape and bureaucracy. So I sort of, try to find some sort of accredited providers, and I engage with them. And I initially engaged with Jared Barnes, who's on the call as well, from We Know Solar. And they work closely with Rainer from Point Solar, and I had some meetings with them. And what I really liked about the approach is the rigorousness. I'm not saying everybody needs to be as rigorous, but I really like sort of the rigorousness of the approach. And I know in the sector we work with, sometimes they do appreciate that sort of rigorousness in terms of implementing systems of this nature. So, I think the key point here was, whoever you engage with going forward, because I think it's something firms need to be doing. Whoever you engage with a solution, hopefully what we've given you today is sort of an outline of the type of questions you need to ask and the type of process that needs to be followed in terms of embarking on this journey. Rainer, we've got a couple of questions. I'm trying to read them out quickly. The first one is, how does irradiance work, and what are the benefits of monitoring it?
Okay, so there's different scales of irradiance. What we normally look at is the GHI, which is your global horizontal irradiance. So to try and understand it, if you look at the Earth and the way that the sunlight hits the Earth, you've got different irradiance charts, which is direct irradiance. It might be reflected where your UV gets through clouds, or even reflecting from panels. The reason why we look at the irradiance on a specific area, because it gives us an average calculation method of what a particular area would generally produce over the year's time. You can imagine the two differences in the Western Cape. You will have, in the winter months, you will have weather issues with rain, where up in Gauteng, you will have clear weather. So each specific area is different. And the reason why we measure irradiance during the actual system installation is to make sure that if you've got a load shedding cycle coming up and your battery is not fully charged, we either need to switch back to the Eskom supply or your generator to supply to ensure that your battery will be charged back up, because maybe at that point in time, your solar panels cannot produce the amount of power that you immediately need. So we need to make a shift change. And that's where the monitoring control of irradiance is very specific. And I hope that it's a very brief answer, but we can go to it in detail in something else.
My understanding that data is available, so firms can go and find out what the radiance of their area is. I know the Western Cape is a lot better than KZN, for example, but it's pretty consistent. So you can get historical data or information on the radiance levels, RR levels within your area to give you an idea of how the level of sunlight.
100%. The thing is, what we need to keep in mind, in South Africa, we're actually very fortunate. Our irradiance wattage percentage per square meter is almost double to that of Europe. So typically in Europe, you will find that the irradiance in the UK is around about 800 to 900 watt per square meter. Where in South Africa, we can go anywhere between 1,200 and 1,700 watt per square meter. So that gives you the performance, the potential performance of the system and how much you can achieve from a solar panel.
Excellent, thanks. We have a question from Steve Tandy. Recommended panel cleaning process for medium-sized installation. I mean, is the case of wiping it with a cloth, or is it more complicated than that?
No, it's a bit more complicated than that. The panel cleaning process obviously is to remove the dust. So you don't want to cause a static on the glass itself that will actually accumulate more dust. So what we generally use is a soft detergent on a very mild solution. And to be honest, a normal dishwashing liquid in water. With a squeegee, and I'm talking about a small installation on this stage, like a residential installation. When he refers to a medium-sized installation, it's going to depend on what kilowatt scale. There is some automated, very efficient equipment in the market today that's actually robotic controlled, that you can actually install on your panel array on the rail system, and you can actually maneuver it up and down quite simply. If you're talking about around about 20 to 30 kilowatt or a 50 kilowatt scale, generally still that will be done by manual labor.
And maybe just a quick follow-up question. How often should you be cleaning your solar panels? Is it a monthly activity, a weekly activity?
It's going to depend on the actual building. We've got some buildings where we're highly dense, populated with surrounding industries that's got a lot of dust, where we have to clean them on a weekly basis. Especially this Brighton body and spray example that we've got at the moment, where they've got an extractor exhaust running from the spray booth that causes a fine mist and it covers the panel. So we have to clean it at least once a month. And then other systems that's in a very clean, like in a commercial type office environment where there's no dust or pollution around, advisable every 6 months at least to do a cleaning of the panels. You can actually see while you are monitoring the system on a daily basis how the efficiency is going down, and you can compare it to the previous month and the follow-up month. You can see that your calculation is starting to produce like 5 or 10% less on a monthly basis, and that's when we decide obviously to do a maintenance call.
And I guess that's the beauty of these systems, is they are electronic. You can monitor them on a daily basis, timeless basis, so you can see if it's starting to drop down. You suspect that it needs some level of maintenance, I guess.
Absolutely, and I think that's a critically important to select the right type of equipment, that you can do the actual monitoring and control remotely. When you've got an emergency situation, you need to do a changeover or a swap. You just basically log in via the internet, and you can make the necessary or required changes without sending somebody out to site. A lot of clients give us a call on an emergency call, and they would request us to maybe change over to only solar or only battery due to a power outage that's only in their specific area or their specific building, and that can be adjusted within minutes.
Excellent. There's another question here from Tristan. If a manufacturing plant does not run 24/7, would you advise just a hybrid system with no battery backup, or would you add a small battery backup solution?
I want to touch base on the grid type system. If you're purely looking at daylight hours, meaning from 7 till 4 in the afternoon, we prefer to rather just do a huge solar array, because you've got normally daylight hours that you're working with. And I would, in the beginning, I won't even consider doing a battery backup, but maybe run a small generator in the initial stages, especially when it comes to cost. So instead of having, if you want to do a 100 kilowatt system, for instance, you would install a 100 kilowatt generator, where if you install a 80 or 100 kilowatt PV array, you will only install a 20 or a 30 kilowatt generator. Now, keep in mind, the cost of the generator will get repaid by the solar system being on the cheap as well. So it's how short is a shoestring? So it's an open-ended question, and I hope I've answered that correctly. If not, let me elaborate on that. But each building with its own demands has got its own unique requirements in terms of a system development.
Excellent. Thank you very much, Reno. Are there any other questions? Please, you can raise your hand and I will allow you the opportunity to ask your question. If anybody from the panel, well, any of the participants would like to ask any additional questions, I mean, take advantage of the opportunity. Reno's got a wealth of knowledge. He has worked for Eskom in the past. Don't hold that against him. But he's got a wealth of knowledge. And like I said, through my engagement, I've realized that as well. So if anybody would like to ask any specific questions, both in terms of, you know, what you're looking at doing, or you're looking at sort of evolving your system, because I know a lot of firms have solutions in place. They're looking at ramping those systems up. Now's the opportunity. Like I said, just raise your hand and I will definitely allow you the opportunity. Otherwise, if not, we will look at closing the session shortly. Maybe while we are doing that, I'm just going to just share my screen again, just to formally wrap up, and unless there is anything else. With me. I'm just going to do it like this. It's probably simpler. All right, so yeah, so I think we've covered it in the major takeaway points. I think it's important that you have an idea of what you're looking for. You do engage with your provider, ask them the relevant questions. I think you emphasize the importance of the municipality or the provider as well, understanding what their particular requirements are in terms of implementing your solution. So I think we've covered a lot of stuff, and I think I must thank everybody. I mean, we did engage with firms in advance, so we tried to better understand their needs and requirements, and obviously requested that Reno look at including those in the session. So I think a lot of the questions that would have been asked were covered in today's session. So thank you very much for that. Again, obviously, I'd like to thank everybody that participated in today's session. Obviously, Reno, I'd like to thank you from Point Solar. Like I said, I've also engaged with Jared Barnes from, We Know Solar. And I think, I've learned a lot in terms of this particular process. I have shared the evaluation poll. So again, please rate today's session, both in terms of the facilitation as well as in terms of the management. What I failed to mention up front is it's always our intention that everybody that participates in any of our session leaves with at least one new idea, something that they weren't fully aware of. So I do trust that everybody did find benefit in today's session, and there is something new that they have derived. And as I've mentioned, the recording will be made available to our member firms. In the poll, and I think I've also asked about joining the WhatsApp group. So we've put together a WhatsApp group. Several other firms have requested this, and it's another communication channel. It won't be a chat forum. It's just basically going to be for letting people know about upcoming events and obviously sharing relevant information. And we'll obviously look at following up with firms after the fact. Unless there's anything else, I don't see any hands. I'd obviously once again like to thank everybody for participating. As I mentioned, we will be having a session I think it's on the 22nd of February on the supply chain challenges. We've got Dave Watts from the South African Freight Forwarders Association who's going to participate. And thus far, our panel also comprises Paul Kenny from Smith Manufacturing, as well as Rudy van Niekerk from H&R Africa. And they'll just be sharing their insight in terms of, what are the challenges they're encountering and how are they addressing these? Because the reality is the supply chain challenges and the port issues, like the load shedding issue, is not going to go away. So firms need to say, how are we going to be resilient and ensure that we are able to continue operating in this challenging environment? Rainer, I don't know from your side, if there's any closing comments you'd like to make?
Thank you, Shona. Thank you for the opportunity and for showcasing our thoughts on this industry and the future that holds for South Africa.
And like I said, and if there's any additional queries, please do not hesitate to email me directly or email BMA directly, and we'll obviously look at following up with those queries and responding accordingly. Otherwise, thank you very much for everybody that participated. I'm going to end the webinar shortly. Take care, stay safe, and look forward to engaging with you in February.
Thank you so much.